Hey, welcome to our next section, Sample Databases. In the previous chapter, you learned how to create a learning environment and started writing some serious SQL code. In this section, we'll guide you through some of the best sample databases which can be used to test almost any SQL Server feature and prepare yourself for the production environment. Before beginning with the samples, I'll briefly explain the basics about relational database concepts and the process of normalization. So we'll cover different databases like the Northwind database, Pubs database, AdventureWorks database, and Worldwide Importers database. Now we move on to the first video of this section that deals with normalization. In this video, we're going to take a look at relational database concepts, the first normal form, second normal form, and the third normal form. Relational databases consist of many objects, and the most common of these is a table. A table is a logical structure or relation for storing and retrieving rows of data. It's defined by its columns, which are represented by their data types. Every table should have a primary key as a unique representation of a single row. It's usually a single column that either hosts a sequential number or a unique identifier that would never be used more than once. Tables can also contain two or more columns that together represent the unique row of the table. A table can also host foreign keys which describe its table reference or relation to another table. For example, a student table has a unique student ID column, and the same student ID is then represented in a grades table to tie the actual grade to the student. This allows for student to have none, one, or many grades, and requires that student records to exist before the grades can be entered. Database normalization is the process that seeks to eliminate the need for multiple repetitions of the same data. It implies a specific form of field and table organization that will minimize data redundancy and dependency. Therefore, the process of normalization often requires the division of large tables into smaller tables and defined relationships between them. The objective is to isolate data so that additions, deletions, and modifications of a field can be made in just one table, and then propagated through the rest of the database via the defined relationships. Edgar F. Codd published an article, A Relational Model of Data for Large Shared Databanks, in which he introduced the concept of normalization, and what we now know as the first normal form, or 1NF, that laid the groundwork for the theory of relational databases, and the rules for how they should be constructed. Codd's 12 rules are a set of 13 rules numbered 0 to 12 that describe the requirements for what should be considered as a relational database. Codd went on to also define the second normal form, or 2NF, and third normal form, or 3NF. So let's talk about the first normal form. Here, every table must uniquely represent each row, not carry any duplicate rows, and not have any repeating groups. For example, a student's table with the attributes name, city, email address, phone number 1, and phone number 2. The phone number attributes are a repeating group, and the table should consist of 4 columns, that is name, city, email address, and phone number. Now, with respect to the second normal form, the table must meet the criteria of 1NF, and any of the non-key attributes cannot rely on a subset of the key. As a student might have several phone numbers, this model might generate many rows for one person, which is termed as redundancy. If, hypothetically speaking, name uniquely represents a student, the model should be students with the attributes name, city, email address, and phone numbers, with the attributes name and phone number. Now, in the third normal form, the table must meet the criteria of 2NF, and every non-key attribute is directly dependent on its key, a superkey. For example, a students table with the name students having the attributes student key, name, department, department location is dependent on the department, not the employee. To adhere to the 3NF, a better solution would be locations with location key, name, departments table with department key, name, location key, and employees table with attributes employee key, name, department key. That's quite simple. I'm sure you got it. Fine. In this video, we learned about different forms of normalization.